Hey folks, I just want to show you real quick how to take our mobility equation and apply that to some simple gripper mechanisms. So the idea is we want to figure out what the degree of freedom we have represented in the skeleton diagram is to make sure that we have enough constraints and ground points or anchor points to limit the motion to what we need it to be. Looking at this very simple first example here, it's a simple angled gripper. Here I've got gears that are actuated, and I've got linkages that are attached to those gears. And so as the gear rotates, of course the linkages are attached to those gears. That forces the fingers of the grippers in to grab an object. It's obviously an angled gripper. And so if I want to break this type of motion down using Grubler's equation, that mobility equation, we will need to identify the number of links, the number of lower pairs, and the number of higher pairs. And so the number of links, for this one, pretty simple. I've got one link here. Now, because this link is attached to this gear, the link and the gear together are one link. Same thing over here. And of course, I've got the axes of the gears that are anchored to the ground. That's going to constitute another link as well. So here I've got 3 links. If I'm looking at the number of lower pairs, if you guys remember, that includes revolutes, prismatic or slider mates, screw, bolt relationships. For this one, it's pretty simple. I've got 2 points that I can revolve around. I've got 2 revolute joints. So L is going to be 2. And here, since we have a gear relationship, the gear teeth constitute a higher pair, and so that's going to be 1 higher pair. So if we write out Grubler's equation, I'm sure everybody remembers that. You got 3 times n minus 1 minus 2 times L minus h. And so just plugging in numbers, I've got 3 minus 1 minus 2 times 2 minus 1. 3 minus 1 is 2 times 3 is 6, minus 2 times 2 is 4, minus 1. 6 minus 5 is, of course, 1 degree of freedom. And so now I know that the degree of freedom that I expect from this mechanical device does in fact match what we get from the mobility equation. So that's about as simple as your gripper design can get, especially with 2 gears with the linkages attached to them. If we want to do something more complicated, that might be better suited for grabbing something like the building blocks that we're designing our projects around. We want to use a parallel grip mechanism. And so obviously we got something that's a little more complicated. And if you remember how the parallel grip, the 4-bar linkage gripper is put together, this guy right here is 1 single linkage. Oof, that's a bad sketch right there. Both the fingers are 1 single linkage with a revolute at the end point, a revolute somewhere in the middle. And so that's, of course, going to affect how we analyze our mobility equation. And so if we were to just write this out, the number of linkages are going to be obviously the fingers, so 1 and 2. I got 4-bar linkages connecting the fingers, so 3, 4, 5, 6. Here I've got 6 things that are anchored to the chassis. Since those are all anchored to that same chassis, it's going to count as a single linkage. And so it looks like I've got 7 linkages. If I'm looking at the number of lower pairs, in this case, it's, again, just going to be those points where I can revolve around. And so 1, 2, 3, 4, 5, 6, 7, 8 revolve joints. No sliders or anything else to worry about. And of course, we got the gear relationship, which represents a higher pair, and it's just one of those. So writing out the mobility equation, I've got 3 times 7 minus 1 minus 2 times 8 minus 1. So 7 minus 1 is 6 times 3 is 18, minus 2 times 8 is 16, minus 1. That adds up to 17, so 18 minus 17 is, again, just 1 degree of freedom, which is what I would expect from understanding how this mechanism actually works. And what that tells me is that I've got enough linkages, I got enough anchor points, I got enough joints in here to actually get that 1 degree of freedom. So if I ended up with something that's got 0 or negative degrees of freedom, obviously I've got too many linkages in there, or I got anchor points in an incorrect place. That's going to keep my gripper from moving. If I've got more than 2 degrees of freedom, maybe I need to restrict the motion a little bit in order to maintain the 1 degree of freedom we need to grab and release a building block. But we can see, using this degree of freedom analysis, the comparison in complexity between the parallel gripper and the angle gripper. If you look at the number of links and joints required to get that 1 degree freedom out of an angle gripper, it's pretty simple. If we move to a parallel gripper, suddenly we have a lot more complexity in this mechanical device. Same degree of freedom. Now, of course, there are advantages to using a parallel gripper over an angle gripper, but of course that comes at a cost. There's a trade-off in terms of complexity, which we can see by breaking down the mobility equation. So give this a shot. You should have a couple gripper designs down on paper. Go ahead and analyze them using this mobility equation. See what you come up with.